So we are beginning a new unit called, or chapter 3 in the book. So we just finished chapter 1. We skipped chapter 2, which is about proofs. And then we are jumping into chapter 3, which is, it kind of builds upon what we learned in chapter 1, okay? Today I'm going to cover 2 sections in one because I don't think it's necessary to teach them separately. The title, we're going to go with the title in section 3.2, which is parallel lines and transversals. And out of these 4 words, you might only recognize really 2 of them, right? A line, and then I guess and maybe when it comes to parallel and transversals, there's a question mark there for you, okay? So to introduce us to these 2 terms, I want to start off by thinking about this idea that 2 lines can either be, and then there's 3 options. So if you imagine, driving down a street, and you, every so often in a car, you will approach what we call an intersection, right? And usually at an intersection, there's a light. You stop, you go, you wait your turn. And so one of the relationships that we can have between 2 lines is that they can intersect. Okay, so the first option is they can either be intersecting, okay, which means that they meet at a point right here, right? This is what it means to intersect. And then the second option is that they can be what we call parallel. Or in other words, they can never intersect. Okay, they can never intersect. So I think about, okay, so for example, like on the freeway, like on the east side of LA, there's a freeway here that's called the 60 freeway. And then there's a freeway right above it called the 10 freeway. And then there's a freeway even higher above it called the 210 freeway. Right? So these freeways, for a certain amount of time, they're running the same direction, and they don't cross each other in that region, right? And so if that's the case, we would call them parallel. Parallel. Just another quick example, like when you look on a football field, right, you have all the yard lines, and we would say that these yard lines are parallel because they never intersect. And if I can just add a symbol here, one common way that we express parallel is with these 2 kind of diagonal markings. It's kind of like chopsticks, so like that. That means that it's parallel. So for example, if I were to write segment AB is parallel to segment BC. Actually, that would never happen, but if I were to write segment AB is parallel to segment XY, right? That's one way to express it. So 2 lines can either be intersecting, they can either be parallel, and then what is this third option here? And this is a little bit more ambiguous, and the way that I would describe it is this. One form of transportation that you'll see on the ground are cars, right? So cars go back and forth, but then if we go up into the sky, there's another form of transportation, right? And that form is the form of helicopters. Okay, so I'm not sure how to draw a helicopter really well, but let's just, I guess we can just attempt it. So there's, for example, if that's a helicopter, it's flying in the air. So I would ask you this: do helicopters and cars, if they're doing what they're supposed to do they ever intersect with each other? No. Now, does it matter if they're going in the same direction or if they're going, so let's say the helicopter was going this way, and let's say the car was going this way, would that affect them at all? No, because the helicopter stays in its airspace, the car stays in its space as well. And then even if we go a little bit higher than that, right, we have airplanes. Okay? And do airplanes, if they're doing what they're supposed to be doing, do they and helicopters and cars, do they intersect each other? No. Okay? So what this term is called it's called skew. Okay? Skew lines also never intersect. But one thing I should have added with parallel is they never intersect in the same plane. So parallel lines have to be in the same plane. I hope that makes so. They always have to exist in the same flat surface, whereas skew lines, they never intersect outside of the plane. So, I mean, I think it would be good to show you in person, but if you have a line going this way and then you have a line going this way, you might think, okay, they're going to meet. But actually, I want you to change your visual frame. So imagine that this is the plane, and imagine that this is the plane, right? So two sheets of paper that are right above and below each other, these guys are never going to meet, no matter what direction you go. So that's what it means to be skew. I hope that makes sense, okay? And then so that's what it means to be, so what we're gonna do in this section is we're not gonna talk so much about intersecting, we're not gonna talk so much about skew, but we're gonna talk about this really important one, parallel. So how do parallel lines help us? And then before we talk about that, we're gonna introduce this second word, which is transversal. And a transversal is simply a line that cuts through two other lines. So imagine if I have a drawing like this. Here are two lines, line number 1 and line number 2. And the line that cuts through it, like that, this is what we call a transversal. Okay, and so we can do that in many different ways. So even if I have two lines that go like this, still there's a transversal that can cut through right there. Okay, so that's the first part. So parallel lines never intersect and they're in the same plane. Transversal is a line that cuts through two other lines. So let's consider this scenario, and this is the classic scenario of this chapter and really a big part of geometry. When we have two parallel lines that are cut by a transversal. So first, let's draw two parallel lines. Okay, this is how we would show two parallel lines, by having them not meet. Okay, and actually the way that we indicate that they're parallel is like this. Okay, in the previous section, we learned that we can put something like this to show that two line segments are the same size, right? Like the midpoint formula, for example. But in this case, when we use this little arrow, these feather markings, this indicates that two lines are parallel, that they never ever meet. And when we have those two lines cut by a transversal, so we'll just draw a line that goes straight through like that, I want you to notice what forms. So we have an angle, another angle, another angle, another angle, another one, and another one, and then another one, and then another one. And we have 8 angles. So when we have two parallel lines cut by a transversal, we form 8 angles that have unique relationships to each other. Now, let's just make a note here, and let me see my... All right, so types of angle relationships that form. And you know what? Let me just redraw it one more time here, just so we are on the same page. There we go. And then 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 1, 2, 3, 4, 5, 6, 7, and 8. And then they're parallel and they're cut by a transversal. So the first couple that I just want to emphasize, we already know these ones, okay? So we already know, and this is from chapter 1, we already know, for example, the vertical angles. In a nutshell, vertical angles are whenever you have two lines that intersect, they're the ones that are right across from each other like that. So just some ones that we would notice, like angle 1 and angle 3, right? And then we could say angle 2 and angle 4. Then we can say angle 5 and angle 7. And then we can say angle 6 and angle 8. The second type of relationship we know is linear pair. And these are the ones that form a line together. Okay, so here's one guy, here's another guy. And we know that linear pair, these guys are supplementary, meaning that they add up to 180 degrees. And then we also learned another type of angle relationship called complementary, which means that these guys add up to 90 degrees, right? So this should all be a refresher for us. Now, what about the parallel lines that are cut by a transversal, right? All of a sudden, we're introduced to these new kinds of relationships. And so to go ahead and describe that for us, I'm going to draw each type of relationship. So I'm going to draw this kind of over and over and over and again. Okay, so here are the two parallel lines. And then we'll go with this guy. Then we'll go with that guy. Okay. And then once again, I'll draw another pair here. Parallel lines cut by transversal. And then I'll go ahead and mark this guy with this guy. And notice the marking I've used are a little bit is a little bit different here, right? And then the third type of angle relationship we're going to talk about like this. Okay, is that and that? And then the fourth and final type would be somewhere around here, like that. And we can say this guy and this guy. And so really, those are the four that we need to know. And so let's name them all. The way that I want you to envision it is that whenever you have two parallel lines cut by a transversal, I want you to think of this as the interior, and I want you to think of these guys as the exterior. So the area in between the two parallel lines, that's what we call the interior. And then whatever is outside of our boundaries, that's what we call the exterior. So when two angles are when they're both in the interior, we're going to call them interior angles. But then the term we're going to use is called alternate interior angles. So that's what these are. So they alternate. They go from this side, and then they cross over the transversal onto this side. So another set of alternate interior angles would be this guy, and then he crosses over onto this guy. Okay, that's what it means to alternate, to cross over the transversal. All right, the second type of relationship here is this. And once again, when we look at our angles here, we will notice that they are both on the interior side of our two parallel lines. So these also are interior angles. However, they do not cross over. They stay on the same side of the transversal, and that's why it's called the same side interior angles. Okay, so the same side interior angles. The third type of relationship, and you know what, let's draw one more set of same side interior angles here. So this one and this one, for example. Okay. The third type of angle relationship is called, so when we look at this one, no longer are we interested in the interior, but now we're interested in the exterior. And by this time, if you can catch my drift, you can probably tell me what this is called. It is an exterior angle, and it's what kind? It's an alternate exterior angle, because it alternates, it crosses over the transversal onto the other side. And then the final type is called corresponding. And so this one's a little bit tough to remember, but as you do more and more of these, it'll get easier. And I want you to notice one is on the interior, and then one is on the exterior. So we can't really call it an interior angle or an exterior angle because it's both. And so that angle relationship is called corresponding angles. Okay? And so just to sum it up before, so I guess we'll just leave it here. But to sum it up, we would just say a couple things. So if two parallel lines are congruent, are cut, by a transversal, then there's a bunch of different statements we can make. So here's statement number one. Alternate interior angles are congruent. So just once again to visualize it, here's an alternate interior angle, and I want you to notice when you kind of eyeball it, this angle and this angle, they look like they're the same size. And that's a very special relationship that exists between alternate interior angles. In the same way, we can say that about alternate exterior angles are congruent. They're the same size. Here's an alternate exterior angle right here, right? They're the same size. And then the third statement we can make is that corresponding angles are also congruent. So remember what corresponding was. These are the ones that have one on the outside, on the exterior, and then one on the interior like that. And they're on the same side. So corresponding angles are also congruent. And then the last one here, same side. And I purposely left this one for last because it's a little bit different. So when we look at same side interior angles, for instance, right, same side, so we would look at this guy and we would look at this guy. And when you look at the size of the angle here between that guy and that guy, we might notice that they're very different. One is acute and one is obtuse. So these are not congruent, but these are, and it all comes back, doesn't it? These are supplementary, meaning they add up to 180 degrees. Okay, so to wrap it up, there are 6 types of angle relationships that you need to know. Vertical angles, you need to know linear pair and supplementary and complementary, all that stuff. And then we need to know alternate interior angles, same side interior angles, alternate exterior angles, and corresponding angles. And we need to know all of their relationships here. Okay, they're all congruent.